Hello, everyone. My name is Celeste Kim, and today I will be presenting on the study whole grain wheat has a prebiotic effect on the human gut microbiota, which is a double-blind, placebo-controlled crossover study. This study was published in the British Journal of Nutrition in 2008 by Costabile A, Klinder A, Beva F. Let's get started. First, I'll go over briefly what we'll be talking about during this presentation. I'm going to start with the background of the study, which will cover key terms and the objective. Next, I'll move into the design, which will go over the sample and methods. Then we'll move into the results, where we will discuss a few of the relevant figures as well as the statistics. Finally, we'll end with the discussion, which will go over the strengths and limitations of the study, as well as my thoughts and the relevance to the future of the dietetics and nutrition field. To understand the study, we first need to understand why the researchers were interested in the whole grain intake in the first place. First, some key terms. We have whole grain, which will be abbreviated as WG, and that includes the bran, germ, and endosperm of the wheat grain. You can see that in the diagram to the bottom right with each word kind of pointing to where it's at on the grain. Next, we have wheat bran. So that is the outer layer of the grain. You can also see that in the diagram to the bottom right. Wheat bran is high in fiber, but it is not the whole full whole grain. That will be abbreviated as WB. It removes the endosperm and the germ. So it may be lacking some micronutrients as a result of the removal. Next, we have gut microbiota, is defined as a community of microorganisms living in the intestines. We have prebiotic, which is non-digestible plant fibers that become fermented by the beneficial microbiota in our intestines. And finally, we have bifidobacteria and lactobacilli. So these two bacteria are important because they are considered beneficial bacterial groups and they are the target in this prebiotic research. Now we want to get into the why of why the researchers were looking into whole grain intake. They were interested in whole grain intake since increased intake is usually associated with beneficial health effects, such as lowering the risk of chronic diseases. This includes some cancers, diabetes, obesity, and cardiovascular disease. Typically, whole grains are recognized as having an inverse relationship with chronic disease, meaning the more whole grains you intake, the lower the risk of chronic diseases, and vice versa. Also, at the time of the study, no previous studies were conducted on the microbiota modulatory capability of whole grain cereals. When we're talking about modulatory capability, we mean the ability of our body to intentionally regulate and adapt the function in response to changing conditions. The researchers also wanted to look at the influence on the colon from functional foods. So when we talk about functional foods, we're referring to foods that have beneficial health effects outside of just their nutritional impact. So this includes both prebiotics and probiotics, and probiotics are foods that provide live bacteria. So the overall question was, how do whole grains create these benefits in the body for us? There were two main objectives to the study. The primary objective was to analyze the impact of whole grain wheat on human intestinal microbiota compared to wheat bran. Specifically, it's assessing um, the ability of whole grain compared to wheat bran to increase numbers of the beneficial bacteria. The secondary objective was to determine the relative impact of whole grain and wheat bran on both biomarkers of gut health and blood lipid parameters. So, samples of the biomarkers of gut health and bowel habit and fecal water genotoxicity. Now we will move on to the study design. Let's talk about the sample first. I wanted to go over the inclusion and exclusion criteria. So the inclusion criteria were that participants had to be healthy adults between the age of 18 to 50. Their BMI had to be between 20 and 30 kilograms per meter squared. And prior to the study, they had to fill out a medical questionnaire. And that questionnaire would determine whether they were generally healthy or not. And for the study, they had to be considered generally healthy. The exclusion criteria list included evidence of mental disease or physical disease or major surgery, history of drug or alcohol abuse or smoking, lactating or planning future pregnancy, severe allergies or abnormal drug reactions, chronic constipation, diarrhea, or other gastrointestinal complaints, the use of gastrointestinal motility drugs, laxatives, or studies with the intake of experimental drugs for 4 weeks prior to the study, antibiotic use within the 6 months, and former participation in prebiotics or laxative studies within the past 3 months. With that criteria, they were able to recruit 31 healthy volunteers. Initially, it was 32 volunteers, but one of the volunteers did have to drop out. For the methods of the study, it was a dietary intervention study. We'll go into exactly what the intervention was later, but I think you could kind of guess from the picture and what I've been saying. And it was a double-blind, randomized, placebo-controlled crossover trial. Now getting into the intervention and timeline of the study. Before starting the study, all 31 participants were placed on a 2-week restricted diet that included no whole grain or wheat bran cereal. After this 2-week period, participants were randomized into 2 groups. Group 1 started with whole grain cereal for 3 weeks, followed by a 2-week washout period during which other foods could be consumed, but no breakfast cereal could be consumed. Then they would move on to 48 grams of wheat bran cereal for 3 weeks, followed by another 2-week washout period. Then for group 2, it was a similar structure where they started with 48 grams of wheat bran cereal for 3 weeks, not whole grain, then followed by a 2-week washout period with no cereals, then 48 grams a day of whole grain cereal for 3 weeks, and then a 2-week washout period. So during these washouts, again, no breakfast cereal was consumed, and all testing materials were packaged, labeled, and randomized by Cereal Partners UK prior to the study. When talking about how this was a double-blind study, the investigators were not aware of which treatments the volunteers were taking, and the volunteers/participants were also unaware of which of the 2 breakfast cereals they were given for each period of time. Also, with it being a crossover study, it means that each participant received both cereals at different times, as you can see on the slide. I thought this was really interesting since it did reduce the person-to-person variability as each person served as their own control of how they reacted to the cereal. For measurements, the researchers collected stool samples to assess biomarkers of gut health and microbiota population. From these stool samples, they were able to assess bacterial counts in feces, short-chain fatty acid profiles, and fecal water genotoxicity. Throughout the study, they also assessed the fasting blood lipid panel. You can see all that was included in there on the slide. They also did a 24-hour urine panel, and the participants also kept daily diaries of any symptoms and the stool frequency and consistency. Moving on to the statistics, they first used generalized linear modeling to make sure there was no carryover effect in the crossover study. When we talk about carryover effect, this means that they wanted to make sure cereal that was eaten did not influence the body's response to the second cereal that was eaten. After that, they used a one-way ANOVA test to see whether there were different outcomes of the baseline whole grain intake period and the wheat bran intake period. Finally, for a Tukey's post hoc test was used to figure out which specific comparisons were significant. The comparisons include baseline compared to whole grain intake, baseline compared to wheat bran intake, and whole grain to wheat bran intake, and the significance was less than 0.05. So what exactly are these tests answering? The way that I like to understand these tests is that the generalized linear modeling test is answering whether the crossover or the carryover effect um, messed up the results, or if there was any carryover effect. The ANOVA test is assessing whether there was any statistically meaningful difference between the periods, and the Tukey's test assessed which exact groups were different. So with that, let's go into the results. So for figure one, this is an overview of the treatment. I think this figure gave me a really good idea of when the measurements were exactly taken, since we wanted to compare baseline to whole grain to wheat bran. You can see at the top that RD, all of the participants had a restricted diet with no cereals. Then it moved on to the first treatment, followed by the washout period, followed by the second treatment, and then another washout period to finish it all off. Um, and that top bar is group one, which had 16 participants. Then the middle bar is group two, which had 15 participants, and it followed the same order of restricted diet, treatment, washout, treatment, washout. At each point, you can see where the tests were taken. At the beginning of treatment one, after the restricted diet period, this was their baseline test, so day 0. And it included a stool sample, 4-hour urine sample, and a blood sample. Then 3 weeks go by, everyone's eating their cereal. At the end of treatment period 1, another test was conducted. Then everyone goes without cereal for 2 weeks and then begins treatment 2, where another sample was collected. Everyone goes on eating their different cereal now, and after 3 weeks of eating their cereal, another test is conducted. And then we have a 2-week washout period after all the treatments are over. And then it has been 73 days and all of the samples are collected. I hope that clears things up a little bit about how the study was set up. Next, we will move on to figure 2. And I think that this was one of the most important findings in the study, since this figure did strongly support their argument about the prebiotic effects. You can see on the table that when participants are consuming whole grain wheat, it significantly increased the levels of bifidobacteria compared to the wheat bran intake. So you can see that right in the middle of the chart here. So this area is pre-wheat bran, pre-whole grain, and then whole grain. Yeah. Lactobacilli also increased with both cereals, but it was increased greater with a whole grain intake. And lactobacilli is going to be the bottom row here. Other than that, there the other bacterial groups really didn't change much. But this was the main evidence of the study showing that the whole grain cereal did have a higher prebiotic effect. Exciting. Let's move on to table 3. So this looks at the biomarkers of gut health. It examines bowel habits and gut-related symptoms that were recorded from the participants' diaries. From this table, we can see that wheat bran has increased stool frequency more than whole grain wheat, and this was found to be significant with a p-value of less than 0.05. Whole grain had a greater proportion of formed stools. Wheat bran had more soft stools and more flatulence with a p-value of less than 0.001. Despite these differences in values, neither treatment of either whole grain or wheat bran caused adverse symptoms overall, um, which is great. Let's move on to figure 5. So this will go over the blood lipid parameters. As you can see here, each chart is labeled A through F. A represents triglycerides, B is total cholesterol, C is HDL cholesterol, D is blood glucose, E is insulin, and F is non-esterified fatty acid concentrations. Between these, no significant differences were observed in the fasting parameters across the different feeding periods. One reason for this might be due to the short 3-week trial period for each feeding period. So, based on all the figures, it does tell me that the strongest effects of the study were on the gut microbiota composition, not necessarily the blood markers. But I did want to show this figure just to say, just to show that there weren't many differences, just like how there wasn't a difference in fecal water level genotoxicity. But yeah. So as an overall of the results, whole grain did show a stronger prebiotic effect than wheat bran, specifically with higher bifidobacteria and lactobacilli. Blood and metabolic biomarkers did not really change, which may be due to a short study period, like we discussed earlier. There were some differences in biomarker gut health, but there were no adverse symptoms reported. Now let's move on to the discussion. First, we'll go over the strengths and limitations. For the strengths, it was a randomized, double-blind, placebo-controlled crossover design, which can reduce bias, and also the participants were able to serve as their own control. Another strength is that um, through the stool samples, they were able to detect the microbial changes, and then therefore um, see a prebiotic effect. And they also measured the fecal bacteria population and did not only rely on the reported symptoms from the participants. Now for some limitations of the study. So the study had a relatively small sample size of 31 people. There was a short intervention length of 3 weeks. So, and there was also an open diet outside of the serial intervention. So that open diet could affected the ability to detect some differences. And I also believe there was limited generalizability since participants were all young. Moving on, some of my personal thoughts of the study was that the findings on the microbiota were pretty convincing towards a prebiotic effect of whole grains compared to wheat bran. Um, and it also showed that microbial changes in the intestines can happen before there's even measurable changes in blood lipid parameters. Um, yeah, so because it was just a 3 week period, it was interesting to see that there was microbial changes within those 3 weeks, but there were not blood lipid parameters changes within 3 weeks. But maybe if they tested longer, there could have been. There could have been. Um, I also think that because they directly tested whether the diet intervention changed gut microbiota, it made a really strong argument for why people um, who eat more whole grains tend to have better, since the whole grains actually did change the gut microbiota. Um, and the study didn't just establish an association between whole grain intake and better health overall. They actually proved there was a prebiotic effect. Um, However, I do believe that because of the shortened intervention period, it does not really prove a long-term clinical benefit. Finally, we'll go over the relevance to nutrition and dietetics. I do think this matters to nutrition and dietetics since it supports the recommendation of whole grain foods for reasons beyond fiber intake, specifically supporting the fact that they may have prebiotic effects. It also reinforces the idea that food structure and variety are really important. In other words, the effects of whole grain um, cannot be assumed to have the same effects of wheat bran alone. I also think this study can be relevant to clinicians who may specialize in gut health or patterns for chronic disease risk reduction or prevention. Um, Going back to the food structure point, I think the study emphasizes that even though these two things come from the same plant, they may not have identical effects. Thank you for listening, and I hope this presentation gave you a better understanding of how whole grain wheat may influence gut microbiota and why that matters to nutrition. Thank you.